Alright, here's second video on balancing redox reactions, and I'm going to have two reactions for you today. The first one is going to be acidic solution, so this is just a review from the first video of how to balance them. First thing that we have to do is figure out what's being oxidized, what's being reduced, so let's go ahead and figure out our oxidation numbers. Oxygen is going to be -2, so that would be make nitrogen a +3, because +3 and two -2s, if we add them all up, that will give us an overall charge of -1. Okay, oxygen once again is -2. Now it's going to make chromium a +6, because 7 times -2 is 14, 2 times +6 plus 2. Combine these together, overall charge -2. Okay, chromium by itself as an ion, oxidation number is +3. Let's try to zoom in just a little bit because the camera's having a hard time trying to focus in on. Then -2 for oxygen, that's going to make it a +5 for nitrogen. Okay, so what is being oxidized? What is losing electrons? Well, if we look, nitrogen goes from a +3 up to a +5. Have an increase in positive numbers, it's losing electrons, it is being oxidized. Oxygen has an oxidation number -2 throughout this, so it's not changing. Now if we look at chromium, it goes from a +6 down to a +3, so a decrease in positive numbers tells us that it's getting electrons, it is being reduced. Then next step is we're going to set up our half reactions. And I always like working with oxidation first, don't know why, just do. And once again, leave yourself some space, because we're going to be adding some stuff into this half reaction to completely balance it out. So first thing is we need to balance all non-hydrogen oxygen elements. Well, no, one nitrogen, good to go there. Now, how many electrons are we losing? Well, nitrogen goes from a +3 up to a +5. So it's losing 2 electrons, and since it's losing them, we're going to put them over on the right-hand side as products. Next step is balancing oxygens. Well, we have 2 oxygens on the left, we have 3 oxygens on the right. And the way that we balance the oxygens is we add in water molecules. So now we have 3 oxygens on the left-hand side. Then the last step for right now is balancing hydrogens. Well, we have 2 hydrogens on the left-hand side. We don't have any hydrogens on the right. And the way that we balance hydrogens is with hydrogen ions. Let's do our reduction half reaction. Okay, so balance the all non-hydrogen oxygen elements. Well, we have 2 chromiums on the left and only 1 on the right, so I'm going to put a coefficient of 2. Now, how many electrons are we gaining? Okay, well, if we take this down to a 1-to-1 ratio, so I'm going to cover up this 2 up here in the reaction. Chromium goes from a +6 down to a +3. So each chromium is gaining 3 electrons. And since we have 2 in the reaction, we're gaining a total of 6 electrons. Now balancing oxygens, we have 7 oxygens on the left-hand side. So we're going to need to add 7 water molecules to the right-hand side. And then hydrogens, we don't have any hydrogens over on the left-hand side, but we have 14, 7 times 2, 14 hydrogens on the right. So I'm going to add 14 hydrogen ions to the left-hand side. So once we've done all those steps for each half reaction, now we need to make sure that we have the same number of electrons on both the left-hand side and the right-hand side. So left-hand side we have 6 electrons, right-hand side we have 2. Least common multiple between 6 and 2 is 3, so I'm going to multiply the oxidation by 3. So 3, 3, 3, 6, and 6. Once we do that, we're going to cancel out the electrons, because however many electrons we put into it, we must get that same number out. So those number of electrons should always cancel one another out. Now, as I said in the other video, is if we can cancel or reduce anything else, let's do that, and that's usually water molecules and hydrogen ions. So on this one, if we look out, we have 3 water molecules on the left-hand side. We have 7 on the right. The 3 on the left are going to be canceled out, and the 7 on the right is reduced down to 4. The hydrogens, we have 14 hydrogen ions on the left-hand side, and we have 6 on the right. So these 6 on the right are gone, and the 14 is reduced down to 8. And once we've done that, we should have our final answer. 3NO2 nitrate plus dichromate plus 8 hydrogen ions yields to 3 nitrate plus 2 chromium 3 plus 4 water. And I also said in the last video to kind of check yourself is if everything balances out, you know, the number of each element on each side and also the overall charge for each side, then it should be correct. So let's kind of look at this one. 3 nitrogen, 3 nitrogen. 2 chromium, 2 chromium. 8 hydrogen, 8 hydrogen. Looking pretty good so far. So let's look at oxygens. So 3 times 2, 6, plus 7, 13. 3 times 3 is 9, plus 4, we're good to go there, 13. Now, let's look at the overall charge. 3 times -1, -3, we have -2, plus 8. So we add all these up, our overall charge is a plus 3. Now let's look at our right-hand side. So we have 3 times -1, -3, 2 times +3, plus 6. Combine those two, plus 3. So our reaction is balanced. All right, now, with the last chapter, we already talked about acids and bases. So we can have either an acidic solution or we could possibly have a basic solution. And if we have a basic solution, we have to do one extra step at the end. So this one, what we're going to do, you know, the first part is just going to look exactly the same, one extra step at the end. So we always need to figure out our oxidation numbers. So oxygen -2, manganese plus 7, bromine -1, oxygen -2, manganese plus 4, oxygen -2, bromine plus 5. So what is being oxidized? What is losing electrons? Well, bromine goes from -1 up to plus 5. Bromine is being oxidized. Manganese goes from a plus 7 down to a plus 4. So it is being reduced. So setting up oxidation half reaction. Bromide ion yields to bromate. And go through the steps. Okay, one bromine, good to go there. How many electrons are we losing? Well, bromine goes from a -1 up to a plus 5. It is losing 6 electrons. Oxygens. Well, we have 3 oxygens on the left. So we're going to add 3 waters to the right-hand side. Then hydrogens, well, we have 6 hydrogens on the left. We don't have any hydrogens on the right. So I'm going to add 6 hydrogen ions. Alright, now the reduction. Permanganate yields to manganese 4 oxide. Alright, so going through the steps, one manganese, good to go there. How many electrons are we gaining? Well, manganese goes from a plus 7 down to a plus 4, so it is gaining 3 electrons. Okay, now oxygens. We have 4 oxygens on the left and we have 2 on the right. So I'm going to add in 2 waters to balance that out. Now hydrogens. We don't have any hydrogens over on the left-hand side. Right-hand side we have 4. So I'm going to add 4 hydrogen ions to the left-hand side to balance that out. Now, balance out our electrons. We have 3 electrons on the left, we have 6 on the right. I'm going to multiply the reduction by 2, so 2, 6, 8, 2, and 4. So once again, our electrons get canceled out. We have 3 waters on the left and 4 on the right, so the 3 on the left gets canceled out, the 4 on the right is just reduced down to 1. Then we have 8 hydrogen ions on the left-hand side and 6 on the right. 6 on the right gets canceled out. The 8 hydrogen ions on the left is reduced down to 2. So what we did before, this would be our final answer. Okay, but since this is a basic solution, we have to do one more step at the end. That extra step we have to neutralize hydrogen ions with hydroxide ions. Excuse me. Alright, so looking at our reaction at this point, we have 2 hydrogen ions on the left-hand side. So to neutralize that, we're going to add 2 hydroxides to the left. Now, however many hydroxides we add to one side, that's how many we have to add to the other side. Now, the hydrogen ions and the hydroxides are going to form and give us water. And we already have a water on the right-hand side. So the 2 waters we just produced is going to be reduced down to 1, and the one on the right is canceled out. So now we have a final answer. It'll look like that. And let's kind of check it. 1 bromine, 2 manganese, 2 hydrogen, 8, 9 oxygen, 3, 4, 7, 2, 9 oxygen. Overall charge, we have -1, 2 times -1, so we have an overall charge of -3 on the left-hand side. -1 plus 2 times -1, so -3. Our reaction is balanced. Okay, this should help you out with the whole assignment. If you have any questions, please let me know, and I will talk to you later. Thank you.